All right, this is the continuation of the notes from section 2.5 on the chain rule, starting with number 5. That's one that I had marked that we did not do in class. So notice that we have a function inside of another function because you have this whole binomial that is then being squared. Sometimes people think of that as like u squared, where u is the inside here, the 9x squared plus 2x. That's one way of thinking of this. So u squared is kind of your outside function, and the 9x squared plus 2x is your inside function. When we do the chain rule, if we have a general power rule, which is what we have here because we have a something squared, we pretend that we are just doing the derivative just like normal. So we bring the power to the front, we keep our base, we lose a power, so this would then become a 1. And then because there is a power, or excuse me, because there is a function inside that actually has its own derivative, we use the chain rule to chain along the derivative of the inside. So the derivative of the inside would be 2 times 9, so that's 18, x to the first plus 2. So then we'd want to clean this up a little bit. So this is y prime equals, I could have a 2, and then I'm going to bring this to the front. Now, since none of these are raised to any power higher than the first power, I would actually work them out. So let's distribute that 2 first. So that would make this 36x plus 4. And you would only distribute it to the first parentheses. If you distribute it to both, that's like multiplying by 4, not 2. And then we could FOIL this. This would be 324x to the third plus 72x squared plus 36x squared plus 8x. So if I work it all the way down, I get 324x cubed plus 108x squared plus 8x. So there's the derivative of that function that is a composite function using the chain rule. Okay, another one that I had for us to look at was number 7. This one's very similar. You have that we would take y prime. The inside function here is 2x minus 5, so we would bring our 3 to the front, just as if we were doing the regular general power rule. Keep our base, 2x minus 5, lower the power to 2, and then we have to chain, remember, the derivative of the inside, which is just 2. So I have a 4 times a 3, which is 12, times a 2, which is 24, and then 2x minus 5 squared. Typically, if there's powers involved on the binomial, we don't try to work it out. So that would be the answer for this one. Okay, let's look at number 10. So for 10, a lot of people go, well, do I need to use the quotient rule here? Actually, you don't. If either your top or your bottom does not have an x in it, it's actually better to try to rewrite this like a general power rule. Number 9 we did in class, and we had to use the quotient rule because there was x's on both top and bottom. So I'm going to rewrite this a couple different times. This is 9 over x squared plus 4 to the 1/3. And then I'm going to bring that up so that it's on the same line with the 9. But if we do that, we make the exponent negative. So now I'm going to use my chain rule for the general power rule. So we're going to do 9 is out front times the negative 1/3 we bring to the front, x squared plus 4. Subtract a power, so remember that's like subtracting 3 over 3 from this, so that'd be negative 4/3. And then we have to chain, remember, the derivative of the inside, so that would be 2x. Okay, so let's simplify down. This would be negative 3 out front. This is x squared plus 4 to the negative 4/3. We have a times 2x, so I'm going to put it all together. The negative 3 and the 2 can multiply together to make negative 6x on top. And the x squared plus 4 would be, all to the 4/3 would be in the bottom. So there's my final answer format for that one. Okay? And that's the end of the ones that we skipped that were in section 2.5. So that was a nice short video for you guys.